Hey guys, welcome to this walkthrough on the level 2 2019 level 2 algebra exam. So question 1, solve each of the following equations. 3x squared minus 6 equals to 7x. So right now we have a quadratic equation and we want to make everything equal to 0 and then factorize and then solve for x. So if we move the 7x to the other side, we should get 3x squared minus 7x minus 6 equals to 0. And if we factorize this equation, we should get 3x plus 2 and x minus 3 equals to 0. So we have 3x plus 2 equals to 0, or x minus 3 equals, x minus 3 equals to 0. So you should get x equals to negative 2 over 3, or x equals to 3. And that should be your final answer for this question, and this is just an achieved mark here for both of these solutions found should be just an achieved. Yeah, once again, as I was saying in my calculus video, I don't have the answer schedules with me, so I'm actually not 100% sure on the exact grade for each of these questions. However, I'm just going to base this on the past year papers and what the grades would have been in past year papers, so just like a rough estimate of what the grade is. So not confirmed of which grade it is, but just like a rough estimate. Alright, so 3 over x squared plus 4 over x equals to 5. So in this equation, you have x squared in the denominator, x in the denominator, and you have 5 by itself. So if you notice that if you multiply everything by x squared, you'll actually form a quadratic equation if you multiply both sides by x squared. Or you can just move everything to one side first. So you can say 3 over x squared plus 4 over x minus 5 equals to 0. So if you multiply everything right now by x squared, we'll actually form a quadratic. So 3 over x squared times x squared is just 3. 3 plus 4 over x times x squared. So x times x squared is x squared over x is just x, so plus 4x minus 5 times x squared, which is minus 5x squared, equals to 0. So you can just plug this equation straight into your graphics calculator. So your a value would be negative 5, b value would be 4, and c equals to 3. And if you plug into the calculator, you should get your answers as x equals to 1.27 or x equals to negative 0.47. And that would be your two answers for this question. And this is most likely this is just another achieved question here. Alright, a drug is used to reduce the level of cholesterol in the blood. For a daily dose of the drug, the cholesterol level C in the blood T months after taking the first dose may be modeled by the function C equals to 0.02 T squared minus 6T plus K. So K is the initial cholesterol level, and the function is valid for the first 15 months only. A person with an initial cholesterol level of 9.18 is given the drug. How long will it take for the person's cholesterol level to reduce to 5.05? Alright, so in the question it tells you that K is the initial cholesterol level, and the question tells you that the initial cholesterol level of the person is 9.18. So you can say that K equals to 9.18, and so basically, the cholesterol level C in the blood, T months after taking the first dose. So how long will it take for it to reduce to 5.05? So 5.05 here would be your C value. So that would be the final amount of cholesterol left after your T amount of time has passed. So you can set up your equation right now. So you can say 5.05 equals to 0.02 T squared minus 0.6 T plus 9.18. Alright, so if you notice here we have another quadratic formula, so say 0 equals to 0.02 t squared minus 0.6 t, and 9.18 minus 5.05. So 9.18 minus 5.05, that's plus 4.13. And once again, you can just substitute into your quadratic, this quadratic into your graphics calculator. So a equals to 0.02. B equals to negative 0.6, and C equals to 4.13. So go to equation, polynomial degree 2, so 0.02, negative 0.6, and 4.13. So you should get your answers as T equals to 19.3 or T equals to 10.7. Alright, so right now these are both positive, so right now you have to go back to reading the question. So it says the function is only valid for the first 15 months. So this 19.3 here is actually more than the 15 months that's stated in the question, so therefore this is not a valid solution. So as your final statement, concluding statement, you should say function only valid for first 15 months. And hence 19.3 months is not valid solution. Not valid solution, hence 10.7 months. Alright, so for this question, I'm thinking that a merit grade is available for this question, given that you find your t value equals to 10.7, and you stated that the 19.3 is not a valid solution, so not valid solution, because the function is only valid for the first 15 months. So I'm thinking that if you have both this solved correctly, so both this and this, you should get yourself a merit grade. And to get an achieved, you're possibly just solving for t. So solve for t, both of these values of t. So this value and this value of t, you'll get an achieved grade, I'm thinking. Should be something roughly like that for this question. Alright, C. The polynomial p of x equals to 2m minus 1 x squared plus m plus 1 x plus m minus 4 can be written as a perfect square. Find the values of m. Okay, so in this year's exam, lots of people got tripped off by the perfect square. But I assure you that perfect square means there's only one solution. So basically, a perfect square could be, for example, if I had x minus 1 squared, that would be a perfect square. And for example, I said x minus 1 equals to 0. So the aka x minus 1 times x minus 1 equals to 0. So in this equation, as you can see, there's only one possible value for x to make the equation true, because x can only be 1, as it is a perfect square. So that's basically what the question is trying to ask. So basically, you can just translate this perfect square. This perfect square actually means one real solution. So that's really what the question was asking here. So you know that the discriminant for your one real solution, the discriminant b squared minus 4ac must be less than must be equal to 0. Must be equal to 0, as it only cuts the x-axis once. Okay, so in this equation, your a value would be 2m minus 1, your b value is equal to m plus 1, and your c value is m minus 4. So you should get a quadratic formula, so you should get multiple values of m here. Alright, so b squared, so m plus 1 squared, minus 4 times of 2m minus 1 times of m minus 4. Alright, so if we expand this out, so m squared plus 2m plus 1 minus 8m minus 4 times of m minus 4. So m squared plus 2m plus 1 minus 8m squared minus 32 minus 36m plus 16 equals to 0. Sorry, this is all equal to 0. And now we can simplify even further. So negative 7m squared. Double negative makes a positive. So negative and negative 36m make positive 36m. So plus 38m. And minus 16. So 1 minus 16 minus 15 is equal to 0. And now you can simply plug this into your calculator. So a is equal to negative 7. B is 38. And C is negative 15. So a is negative 7, b is 38, and c is negative 15. So you should get your both your answers. You should get your m value should be equal to 3 over 7. Sorry, this is pretty messy. So m equals to 3 over 7, or m equals to 5. So that will be your two answers for this question. M equals 3 over 7 and m equals to 5. Getting both of these solutions, that should get you a merit grade. And in terms of getting an achieved grade, perhaps getting somewhere up to here maybe will get you an achieved grade. If you can get up to this step here. Alright, so by factorizing, find an expression for find an expression in terms of p for the difference between the roots of the equation px squared plus 4px minus 12. So when they refer to a difference of the roots, you know there's two roots. When there's two real solutions, there's two different roots. So for example, if I had x minus 1 times x minus 3, for example, your roots would be x equals to 1 and x equals to 3. So for this question, it's just asking basically the difference between these two roots. In this case, it would just be the difference would just be 2 for this in this specific case. And this basically, and this is just trying to find make you find a difference in terms of p. So for this question, you're gonna have to use the entire quadratic formula because you're finding the roots. Because you know negative b plus or minus square root of b squared minus 4ac over 2a equals to x, and this x here is all your roots. So basically, it's just asked because you know b squared minus 4ac, this has to be a positive. Because you can't have it's not real solutions to have a square root of a negative number. So this here must be positive. So therefore, you know negative b plus of this it will be greater than negative b minus. So basically, you're just trying to find a difference between this negative b plus of this over 2a, a plus of square root of b squared minus 4ac, and the difference between negative b minus square root of b squared minus 4ac. So if I just did this, if I walk through this question, it might be a bit more clear what I'm trying to do. But first things first, we need to have a discriminant, which is our b squared minus 4ac. So we need to have an a, b, and c value. So our a value right now, it's in this form. So basically, we don't really want it in this form because we can't clearly see what our a value is. Right now, it's px squared. And we want something, we want, for example, ax squared. So basically, we just want this a value by itself. So basically, we're going to expand this out. So we're going to say p squared x squared plus 4px minus 12 equals to 0. Okay, so now it's really clear. So this would be your a value. This would be your b value. And this is your c value. So we're going to be using the entire quadratic formula here. So good thing to write out the quadratic formula so the markers know what you're talking about. So negative b plus or minus square root of b squared minus 4ac over 2a equals to x. Alright, so your b value is 4p. Negative b would be negative 4p plus or minus square root of b squared, which is 16p squared. 4p squared is 16p squared minus 4 times of p squared times of negative 12, and then that whole thing is over 2p squared, so that's your 2a. Alright, so if we simplify this a little bit, so we'll have negative 4p plus or minus square root of negative 12 times 4 is negative 48, so negative 48, and there's also a negative here, so double negative makes a positive, so that becomes 16p squared plus 48p squared over 2p squared. Alright, so now it becomes pretty apparent. So negative 4p plus or minus square root of 64p squared over 2p squared. Square root of 64p squared, you can really, it's pretty simply, you can just rewrite that as 8p. So 8p times 8p equals to 64p squared. So you can rewrite your equation as negative 4p plus or minus 8p over 2p squared. And we want to find the difference between the roots. So we want to find the difference between negative 4p plus 8p over 2p squared, and the difference between the difference between negative 4p plus 8p over 2p squared and negative 4p minus 8p over 2p squared. So basically, you would rewrite your formula as something like this: so 4p plus 8p over 2p squared minus 4p minus 8p over 2p squared. So now it's just a matter of simplifying this. Okay, so first things first, we can add the like terms. So 4p over 2p squared minus negative 4p over 2p squared. Sorry, so basically, you know, double negative makes a positive, so 8p over over 2p squared. Because common denominator, you can just add directly. Alright, so for this... Alright, so now that you have your equation, you can simplify even more. So p and p cancel out, so that becomes 1p here. And a over 2 is 4, so 4. Yeah, for 4. Sorry guys, hold on. Apologies guys, just hold on. I think I might have made a little bit of a mistake here because that was not the answer I was getting previously. Apologies, just hold on for a bit. So negative 4p plus 4p plus minus 4p. Made a mistake somewhere, looks like. Plus, negative 4p, positive 4p plus is 8. 8 over 2. Yeah, apologies guys about that. So I found out what the mistake was. I forgot to add the negative 4p. I accidentally considered it as positive 4p, so that's why I went wrong. So this here is not quite right. Sorry guys about that. It's a careless mistake, so apologies. So that becomes negative 4p minus 8p. That's negative 12p. Double negative makes a positive, so it becomes 4p plus 12p over 2p squared. And that becomes 16p over 2p squared. And now it's just a matter of simplifying. 16 over 2 is 8. And then p and p, this p and p can cancel out. So 8 over p. And that should be our final answer. Yeah, once again, apologies for the confusion with the... I totally just forgot about that negative there. So sorry about that. So getting up to 8 over p, that should get you an excellence grade to get up to 8 over p. In terms of getting a merit grade, I'm thinking if you can get up to here, I think you'll be able to get snitch a merit grade, because you found the equation for the roots that might get you a merit. In terms of getting an achieved might just be an unsimplified form. Perhaps here, that might be an achieved. Yeah, that looks about reasonable to me. Yeah, once again, sorry about that mix up about that negative 4p, but moving on. So use algebra to show that the graph of the function y equals to x minus a times of x minus b minus c squared, c is not 0, crosses the x-axis at 2 distinct points. So basically when something cuts the axes at 2 distinct points, that basically saying that there's 2 real solutions, because if you have a, sorry, not red pen, I don't know. So that's basically saying that the parabola is cutting the axes at 2 different points, so 2 real solutions for x, basically. So your b squared minus 4ac should be greater than 0. But you want to prove that this is greater than 0. You want to prove that with this equation that it's always going to be greater than 0. Alright, so for this equation, you don't actually, your a, b, and c values are not really clear right now. So first things first, you're going to have to expand this out into the ax squared plus bx plus c form. So that's not too bad. So you can say x squared minus ax minus bx plus ab minus a c squared, and that's your expanded form. Alright, so next things, you want to group the just an x and an x here, so you can put this negative a and negative b together. So you can say x squared minus a plus b of x plus ab minus c squared. So right now this becomes really clear. So this is so there's no value behind the x squared, so that means that your a value is 1. So this here is just 1x squared, so a equals to 1. B equals to negative a minus b, so negative a, negative a, negative b. Oh, sorry. And your c value would be this entire thing, which is ab minus c squared. Alright, so now we're going to go into the b squared minus 4ac, b squared minus 4ac. So negative a minus b squared, negative a minus b squared, minus 4 times of 1 times of ab minus c squared. Alright, so a bit of simplifying work here to do. So if you expand this one out, you'll get a squared plus b squared plus 2ab minus 4 times of ab minus c squared. Simplifying this even more, so a squared plus b squared plus 2ab minus 4ab minus 4c squared. Alright, so you can get into your final stages of simplifying. So a squared plus b squared, 2ab minus 4ab, that becomes negative 2ab. Add negative and negative 4c squared make positive 4c squared, so plus 4c squared. And that is your b squared minus 4ac. So right now in this form, it might be really hard to see whether or not this is going to be greater. How is this going to be greater than 0? So in this case, you always have to be keeping in mind that you want to try to find a way in order to make something squared plus something squared, because something squared is always positive given that it's not 0. So if the number is not 0, anything squared must be positive. So that's one way you can prove that your quadratic will always cut the x-axis at 2 points. That's the easiest way. So you're trying to find a way to make this whole thing something squared. So basically, you look at this 4c squared. You see the c squared here. So any number that's not 0, you put into c. It's always going to be positive. So this will always be positive. You can prove that. However, if you're looking at this part of the equation, you can't really say anything about it so far. This could be, for all you know, this could be negative whenever it could be. So you're trying to find a way in order to make this a perfect square. And basically, it's really hard to explain, but that's really. So if you look at a minus b squared, so that's a minus b times a minus b times a minus b, that equals to a squared. Negative b times negative b is positive b. A times negative b is minus ab, and then minus ab again. So that will get you, that's exactly the same as a squared plus b squared minus 4ab. And that is equal to your discriminant. That equals to your discriminant. So now you can easily prove it. So you can say any number squared must be positive. Must be positive. Hence, must be positive unless it is 0. So therefore, a minus b squared will either be 0 or either be 0, because if a minus b is 0, 0 squared is 0, so either be 0 or a positive number, however, 4c squared must always be positive, because c cannot be equal to 0. And that's specified in the question. That's the reason it's specified here. So it says the c cannot be 0, so therefore this must be positive. Hence, it will always cut the x-axis at 2 distinct points. And that should be your explanation for your question. So basically, if you get the a minus b squared plus 4c squared here, if you get just that might just be a merit grade overall for this one. However, if you get both of the justification and the a minus b squared plus 4c squared, should get you an excellence grade. And In terms of getting an achieved grade could be this part. You didn't factorize that could be an achieved, or possibly just probably I'm thinking possibly if you just write it in this form, it could just be an achieved. I'm not too sure, but it's a possibility because you have shown some algebraic procedures, so even this could be an achieved grade here. Alright, so thank you for watching this video on the level 1 question 1 for the 2019 level 2 algebra paper. So I'll be posting the question 2 and question 3 really shortly. Thank you for watching. See you in the next one.